We're going to go over a couple of things from the test on quadratics very quickly, and then I'm going to post them. Couple of things. First off, number one, how to solve an equation, how to find the solutions, which are the x values in these problems. Sounds, to graph it, yeah, it's a pain in the butt to graph the parabola and find out exactly where they cross. Some of them work out really nice. Some of them will work out with fractions, which is impossible to graph and find it perfectly. You've got to use the methods that we know. One that we used already is finding the factors of this trinomial. And that's something fairly easy. First off, you've got the equation written, and it's not in standard form. Ax squared plus bx plus c is equal to 0. They've got it separated and got the constant over here. All you have to do is move the 20 to the other side, make it a positive 20. Now it's in ax squared plus bx plus c, which is all nice. You can look at this and know for sure that because it's minus plus, it is x minus x minus. You know it's x minus x minus. It's a done deal because it's minus plus, it's minus minus, and your two binomials. All right, and when you've gotten it that far, now you're just looking at the factors of 20. What make 20? 1 and 20 don't make 12. 2 and 10, bing, 2 and 10. 2 and 10, doesn't matter where you put them. 2 and 10 go in there. 2 times 10 make 20. 2 plus 10 is 12. It all works out perfect because the last is 20. The oi, outside inside, is negative 2 or 12, sorry, and they both equal 0. That means each individual part, the x minus 2 is equal to 0, and the x minus 10 is equal to 0. So you can figure out pretty simply 2 minus 2 is 2, and 10 minus 10 is 0. So the two, your solutions for this problem are 2 and 10. Those are the two places that your graph, that this parabolic curve that it would create, these are the two places that this graph would cross the x-axis. We know that it would also look like this. It would be an upward opening one. Why? Because it's a positive value out here for a. So we know that it's going to be a minimum. We know that it's going to cross at 2 and 10 on the graph and open up wherever it is down in here. We haven't even found the vertex and the axis of symmetry. Don't need to right now because all they're asking for is the solution, where it crosses the x-axis. Now, I'm going to show you with this exact same original formula. I'm going to show you, hey, there I am, how to solve this using the thing called the quadratic equation. Okay, the quadratic equation. Well, what is the quadratic equation, you ask? It is this formula right here, the quadratic formula. X, your solution, is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, we know that when we've got it written like this, it's in ax squared plus bx plus c form. Okay, we've got it written in this form, and we can just start filling in the blanks in this problem. Negative b. Well, b is a negative 12. So a negative 12, I'm going to make it just plain old 12. Okay, I'm filling in the b. It's a 12. Plus or minus the square root of b squared, which is negative 12 squared, minus 4ac. Minus 4 times a, which is 1, times c, which is 20. Okay, sort of losing place where I'm at. All over the top of 2a. And 2, we know that a, is 1. Okay, now let's work on the stuff that's in the radical. Negative 12 squared, negative times negative is positive. 12 times 12 is 144. Know your perfect squares. Over here, negative 4 times 1 is negative 4, times 20 is negative 80. 144 minus 80 is 64. So inside the radical is 64. Okay, so now we've gotten rid of all this, and we've turned it into this. 12 plus or minus the square root of 64 divided by 2 times 1, that's just 2. Now, some of you have said, whoo, probably in your heads, what's the square root of 64? It's 8. But it's not just 12 plus 8. It's 12 plus and 12 minus, all divided by 2. Okay? Does this make sense? You're going to get 2 answers. What's 12 plus 8? That's 20. What's 20 divided by 2? 10. What's 12 minus 8? 4. What's 4 divided by 2? It's 2. Oh, look at that. We found our solutions to this are 10 and 2, which just so happen to match up perfectly with what we did with our taking the factor of the trinomial. It came out to be 10 and 2, both of them. It's only on, I think, 1 or 2 problems on the test that they want you to use the quadratic formula. So I'm going to put it up here again. Commit it to memory. The quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by a. They want 2 problems where you have to solve it using that. The others, you can use the factoring method. You could use the graphing method. There's a ton of different ways that you could solve these problems. There's no, when it says solve algebraically or solve by just solve it. I don't care what method you use if it works for you. If you use the quadratic formula on all of them, negative b plus or minus the square root of b squared minus 4ac divided by 2a. If you use that and are consistent with that, it'll work fairly well all the time. All right? If you have any questions, send them to me. Right now, all you're really worried about doing are the first few. Do the ones where they ask for the maxes and the mins. I think it's like numbers 3 and 4 and 6 and 7. I'll look at the test. I'll pull it up right now and I'll tell you what ones that you really should start working on right now. Let's see where we're at. Quadratic test. I'd say work on number 5 and all the parts because you should be able to find, let's make it bigger. Work on number 5 where you find the max, the min, the axis of symmetry, the domain, the x-intercepts, all of this stuff. It graphs it for you. All of that, you can find out the axis of symmetry, the vertex. Is this a maximum or minimum? How many solutions does it have? What are the x and y? Where does it cross the y? I mean, all this stuff is right here on the graph, okay? Then later on, they give you an equation right here. They give you an equation that you need to find all of those same things and then graph that function there. Okay, I always say find the axis of symmetry and the vertex right off the bat. If you find the y-intercept where it crosses the y-axis, you can go from there. I know right now because it's positive, it's going to open up wherever it's at. It tells me right there where it crosses the y-axis. Shh, don't tell you anymore. Okay, if you have any questions, just ask. Okay, we can work through this every day by day. So there's no rush. It's Friday. It's due Friday for most. If you've got actual access to a computer, it'll be due next Monday. I'm going to try to have the Google Classroom Meets, whatever thing on Friday for us so we can sit around and look at each other's faces and get a little scared. But I'll be there. I'll be here. If you need anything, just give me an email. Bye.